Good morning, everyone. Hope you're all well. Welcome to episode 3 of the Proxmox course. In this session, we're going to cover clustering, which I'd originally intended to be part of episode 2. However, I felt that was getting too long. Um, and we're also going to cover quorum devices. And this will lead us nicely into discussing HA, high availability. Um, so this is a follow-on from episode 2, and I hope you enjoy it. Okay, I'm back. It's taken me just over an hour, and that includes a cup of tea, so not bad going. And I have now installed the other 3 machines to save you having to watch a repeat of the process we've just been through. So let's go and have a look at those 3 machines, or 4 machines in total. Okay, so I'm back over on my Mac, and we can see this is .230. You might actually find it a little bit difficult to see that because obviously it's quite small, but that's Transam. I've installed Mustang at 231, Charger at 232, and Cobra at 233. So we've now got a total of 4 machines. And what we're going to do is quickly create a cluster, and then that'll be it for today's video. Okay, but so what we do is this. We start off by going to Transam, or it doesn't matter, going to one of the nodes, but Transam's the one we initially installed. We choose data center and we find cluster. It's the 4th one down on the middle tab, and there isn't a cluster at the moment, so it's giving us the opportunity to create one. So we'll create a cluster. What should we call it? Batcave. I haven't explained why I call it Batcave, but you can see that I'm in a fairly small, little, tiny back office, and it has the nickname of Batcave. So I just simply say create. Okay, so a few seconds later it says task OK. Click OK there. Now, notice I'm getting permission denied, invalid PVE ticket. All right. It will do that for a little bit of time while it sorts out the cluster certificates for communicating with other members of the cluster. Okay, so Transam. Click on Transam. Now click on Join Information. And you will notice it comes up with an IP address and a public key that will be used by the other nodes in the cluster. So I now click on Copy Information, and that's all I need to do on Transam. Currently, Transam is the only member of this cluster that we've just created. Now click on Mustang, log in. Okay, so log into Mustang. I haven't got a valid subscription. Whoa. Click on Cluster. Now I can either create another cluster, which I don't want to do, or I can click on Join Cluster. Okay, I can then simply paste. So I've just hit Command V or Control V on a PC, and it's pasted all the information in, apart from, of course, the password of that node. So I will enter the root password of that node and click on Join Batcave. Okay. And in a second or two, it will say okay. In fact, it won't, because now what's happened is we've got new keys. So if we go back to transit, we'll find out it succeeded, but we've lost our connection. And the reason we've lost our connection is we've changed our public-private key pair that we use to communicate with other nodes in the cluster. So if we go back here, we can see that Mustang has magically appeared. Okay. So if I want to actually use Mustang, I now need to reload this page. So click on this, click on reload, and you'll notice I'm actually having to log in again as if it's a brand new session, which effectively it is. And now we can log in, and we are now on Mustang and seeing the cluster. Okay. So what this proves, by the way, and I won't do this again because it's not that interesting, but it proves that you can administrate this. Let's get rid of that. You can administrate this cluster from any member of the cluster. Okay, so that's exciting. So Transam If we go on Transam, we can see we've got 2 nodes in the cluster. So now let's add another one. So we log in. Okay. We go to data center, cluster, join cluster, Command V, put in root's password, click on join Batcave, and again, it will actually appear not to have succeeded, but this is because of the key change I mentioned earlier on. So close that window, and then let's go to Transam, and we'll now see there are 3 nodes in the cluster. And that one will take a second to catch up. Okay, certificates have changed, so we need to refresh this, and we're okay. All right, so we're back in, and we now have Charger, Mustang, Transam. This can be a teeny bit confusing because every time we create a new node in the cluster, there are some changes to the public-private keys, and therefore the browser can get confused. But it's not a big problem. So we've now got Charger, so let's get rid of him to cut down the noise. Let's click on Cobra. Now Cobra I installed, so we can log into Cobra, and that's fine. It's working fine, but it's not a member of the cluster. So go to Data Center, Cluster. We are not in a cluster, so we could create another cluster, but that's not what we're trying to achieve. So we're going to click on Join Cluster. I will type Command V to paste it in. I need to add the root password for that server. And again, it will hang, okay, because of the key change. All right, so not a problem. We're not really too concerned about what Charger does or doesn't see. We're more concerned about going here and seeing what we can see. So it was Cobra. I beg your pardon, I said Charger. So we can see there are now 4 nodes in this cluster. Okay, so now we have a 4-node cluster, which we're going to use for the rest of the course. And the other thing I'd like to point out is if you look at any of the nodes in the cluster, they all have QCAN storage. Okay, so simply by joining an existing cluster, if there is some NFS or Samba or Windows shares attached to one of the nodes, the other nodes will see that storage because we configured it in data center. And remember, changes you make in data center apply to the whole cluster. So any changes you make here that would result in a change on a node would affect all of the nodes. Whereas any change I made when I'd selected an individual node would only apply to that node. Okay, so it's well thought out. It's a lovely design. It's a nice, simple GUI. And as we go through the rest of this course, we're going to get more and more familiar with it. But I hope I proved to you that dramatic as it sounds, creating a cluster is only marginally more work than actually installing a single node. But also remember, in a home lab, 1 node is fine. Not all of us can afford a little, well, they weren't terribly expensive, but my stack of 5-6 servers that I've got there were all bought from an electronics reclamation place. So you can get cheap, cheerful hardware, which would be perfectly fine for setting up a Proxmox cluster. All right, well, I've just applied an OBS update. OBS is the software I'm using to record my videos. And since then, 1 or 2 things have stopped working, so hopefully this won't be too bad. So this morning we're going to talk about the quorum mechanism. And this is not too long, and it's not going to cover everything to do with it because very shortly we're going to cover HA. And quorum and HA are fairly tightly coupled. So when we talk about quorum, really it's chicken and egg. You know, do you talk about HA and then you have to bring up quorum? Do you talk about quorum, then you have to bring up HA? So I thought we'd do a really good, hopefully, introduction to the quorum mechanism. And then in a couple of sessions time, we're going to cover HA. And in HA, which is potentially confusing, we're going to do a lot of practical. We're going to set up lots of different failure scenarios. HA is high availability, by the way, in other words, resilience. I'm not sure if I actually mentioned that. Okay, so let's start looking at some overhead slides that I've created. By the way, give me some feedback. I like using slides because I think they help people whose first language is not English. I think they help people follow what I'm covering, but importantly, they help me remember what the hell it is I'm supposed to be covering. So let's switch across to the presentation that I've prepared just for the introduction, just to start with. What we have here is a few bullet lines to kind of emphasize what quorum is and what it isn't. So it's a voting mechanism. All right, consider a situation where you have a committee that meets once a week and makes decisions about something. So a quorum is a system whereby that committee cannot make decisions unless there are a certain number of members present at the meeting. So what that quorum is something that is defined by the committee itself. They might say we need to have at least 5 members present before we can make changes to our setup. So it's not different really in Proxmox. It uses a voting mechanism, and each machine has a single vote. There must be more than 50% of votes present to proceed. So in other words, in our 4-node cluster, we need at least 3 nodes up and running for everything to be okay. Now, if we had 2 nodes down, then we would be in a non-quorate condition, and the remaining 2 nodes would go into a kind of read-only mode, and they wouldn't be able to make any changes. They wouldn't be able to start up VMs from the other 2 nodes because those VMs obviously have gone down. Now, if we've configured HA, if we've enabled HA, and if we've configured those virtual machines on the failed nodes to fail over in the event of those nodes going down, then this cannot happen at the moment because we're not in a quorum state or a quorate state. So it requires operator intervention. In other words, you become an additional vote. You become the casting vote. You look at the situation and say, oh, I see what the problem is. And then you either fix the problem, or if that's going to take a long time, you can actually change the quorum requirement on the remaining nodes so that they could actually start up the failed virtual machines and they could continue to run. And then when you fix the problem and the 2 failed nodes rejoin the cluster, then they would be brought up to date and the virtual machines would fail back again. This is assuming you've configured HA, of course. Okay, and we're going to cover HA in detail, so we will demonstrate all these things. Right. So it's, as it says at the bottom, it's tightly coupled with HA. So let's have a look at a few scenarios. So the first scenario is a simple home lab with a single node running virtual machines, etc., etc. This hasn't, effectively, it doesn't have a quorum mechanism. The quorum mechanism exists, but you have 1 node and you can't have more than 50% of 1 node running, so the quorum doesn't apply in this case. So what we're more interested in is something like this. Now I've changed the diagram slightly. I've put a dotted line down the middle, and I'm inferring that actually this is a 2-site cluster. So this organization has 2 nodes on one site and 2 nodes on another site. And I'm saying that they have communication obviously between each other because those 2 sites need to be able to communicate so that the quorum mechanism can be maintained. In this case, we've lost Transam. All right, so we've lost a node. However, we've still got Cobra, Mustang, and Charger up and running. And assuming that we've configured HA and that we've actually configured it so that virtual machines running on Transam must restart in the event of failure, then they will restart on Cobra, Mustang, or Charger, and you can actually prioritize where they would restart. So it's kind of logical, pretty straightforward. Do bear in mind that for the virtual machines on Transam, to be able to start on Cobra, for instance, which would probably be the ideal choice because that's site A and you chose those virtual machines to be there initially, then Cobra needs to be able to see the virtual disks of the virtual machines that were on Transam. So this does rely on shared storage, as discussed previously in previous sessions. Okay, so in the GUI, it would show up like this. We'd have a tick box shown, and it would say, yes, we are in a quorate state. But it would also show that there were 3 nodes online and 1 node offline. Now, as mentioned previously, we also have a really powerful command line interface, which I'm not going to cover now, but I'm just going to show you a couple of commands. PVECM stands for Proxmox Virtual Environment Cluster Management. and we've got a status argument that can go with that command, and it comes back and it tells us that this cluster currently has a node missing because it says the expected votes are 4 and the maximum expectation is 4, but the total number of votes that we have is 3. However, a quorum is 3 votes, therefore we are quorate, so everything's fine. Well, it's not exactly. We need to go away and fix the failed transam, but it will continue to operate. Okay. Now let's look at a situation where that wouldn't be the case. So again, it's our 4-node cluster. What we've done, what's happened here is we've lost 2 nodes. We've lost transam and we've lost Cobra. So we have a 2 or more node failure. So we have 2 votes out of a possibility of 4, which is less than 51%. Therefore, what would now happen is that Mustang and Charger would continue to run and continue to serve the virtual machines that they were hosting. However, you would not be able to make any changes, and they would not be able to start up the virtual machines from Transam and Cobra, again, if they were configured in HA as such. So how would this look in the GUI? Then it would come up now, instead of having a nice green tick, we've got a red circle, and it says quorate no. It also tells us that we've got 2 nodes running, but we've got 2 nodes failed. So if we look at the command line and run a PVECM status command, we can see that quorate is no. So we are not in a quorate state because the expected votes is 4, but the total votes we need for a quorum state is 3, as indicated at the bottom. However, we only have 2. So it says activity blocked, which effectively means we're in read-only mode. Now we can actually fix this because, for instance, if we think about the situation here, we might say, right, I can fix Transam and Cobra, but it's going to take me an hour or 2 hours or whatever. And that really I could do with Mustang and Charger carrying on. But you've come in to this situation and you've said, right, I've analyzed what's wrong, and it's safe for me to actually tell the remaining 2 nodes to become in a quorum state temporarily and be able to start up the nodes from the 2 failed nodes. And to do this, we simply say, as root on one of the remaining nodes, we type in PVECM expect 2. In other words, expect 2 votes for a quorate situation, and that's reflected in the status command shown below. Okay. Right, so now we're looking at a situation which is known as split brain, and this is where a Mustang and Charger haven't failed. However, Mustang and Charger cannot communicate with Transam and Cobra. All right, so there's an intersite failure of some sort, and in communications. And obviously this is not impossible. One would hope it's unlikely, because presumably if you care this much to have set up 2 sites, you've also actually configured and built 2 or more resilient networks between those 2 sites. Now in this situation, we have a really dangerous situation because we could, the cluster, what we've effectively got is 2 clusters. We've got the cluster called Site A and the cluster called Site B. Now, if those 2 sites or those 2 clusters thought they were okay to carry on, then they could carry on starting up VMs from the remote site. They could make changes to the configuration that differed between the 2 sites, and it would be chaotic, which is why, of course, in this situation, both of those mini clusters would be in a non-quorate state, and therefore they would both be in read-only mode. And we need to fix that communication problem before we can continue, or take down Mustang and Charger, shut them down, for instance, and then use the PVE expect command to allow Transam and Cobra to continue while we sort out the problem with the intersite connections. Actually, you don't have to take down Mustang and Charger, but it would probably be advisable to do that. So to summarize, the quorum mechanism is designed to protect us from a situation where we had corrupted configuration information because it was not consistent across the cluster. So that's its job. We can always act as the casting vote. So in the event of a situation where we have non-quorate state, we can always step in and say, right, I've looked at the situation and I'm prepared to change the configuration temporarily by using PVECM activate so that the cluster can continue in a damaged state, but at least that allows it to continue while I go away and repair the problem. Fine. Right, so that's an introduction to the quorum mechanism. And remember, it's a really critical part of HA as well. So we will cover that in some detail. When we look at HA, we're going to do a lot of practical stuff because I deliberately haven't done any practical in this section. What I wanted to do was really introduce the theory of this. Then when we come to do the HA section, that will be predominantly a practical example of failing clusters in the nodes that we've looked at now, just now. And we'll also look at what happens if we've configured HA, and what our objective is to keep our virtual machines running as much as possible. So that's upcoming in the next section, where we will cover virtual machines and we will cover containers, how to build them, how to control them, how to back them up, briefly by the way, how to snapshot them, and then the section after that will cover HA. Okay, so I hope you enjoyed that. A reasonably short session, and I look forward to seeing you shortly.